I indeed work for Microsoft and Copilot, but not GitHub Copilot, so not the developer tools, but the Copilot from M365, so the one you see in Teams, everywhere else. Like I suppose I've seen you are using Teams, so I suppose you have M365 in the company, so you are using that. And I'm mostly responsible for the people integration, so which is right now is not the greatest of integrations, but that's why we are there. I only moved in that area in the past 2 months, so 2 months ago, 1st of March. So yeah, we are just trying to make sure that Copilot answers pretty good answers and has grounded answers in your enterprise data and resolving people hierarchies and discovering skills, knowledge, and stuff like that in the organization. But I'm not going to talk about that today. I want to talk a bit about what we do or how we use AI, because Microsoft has been, as you probably know, on the trying to lead the AI wave even since the beginning with the open AI investments and trying to be at the forefront of the change in there. And even since the beginning, our culture shifted a lot from trying to do things without AI, basically doing everything with AI. As you see, Copilot is everywhere, and this is why I said that I think we messed up a bit the names because we call Copilot everything, but there are different things to that. However, the internal culture is so that the first option you have, you use AI, whatever. If it doesn't work, try to fix it and get back at using AI and keep iterating on that. So since the beginning, I used AI for all kinds of things and all kinds of different ways. But at the end of the day, we need to be productive, right? So it's not like, yeah, we can experiment, and we are constantly experimenting as a team, as a group, with all kinds of things. We are actually using both GitHub Copilot and Claude, so it's not like they are competition and we are not going to touch them, but it's the opposite. Let's use that as well, see how it works, and get feedback to our team so that they can also improve in that sense. Just compare them and so on, and do the best with all the tools available. So I have tried a lot of things, but I feel like right now we kind of settled, or personally, I try to understand what is the best thing I can do to actually deliver something, whilst also trying to experiment. So the presentation today is not about, I don't know, fancy workflows and all kinds of, I don't know, I start something now, go on holiday, come back in a week, and the whole Copilot thing is basically implemented. I haven't seen that yet, so I know I've seen on the internet, LinkedIn and so on, there are a lot of stories like, oh, I built this project without, I don't know, doing anything. I just told it, build me whatever, and then I make a lot of money. That didn't work for me, at least up to this point. I have pet projects at home. I work with these things for Microsoft, but didn't manage to get everything done just by clapping my hands or just saying a few words. So the presentation is going to be focused on what we need to do to take advantage of this and to actually become more productive and use them, whilst also staying in control. Because from what I've seen, again, in practice, once we start generating a ton of stuff, how do we actually validate that that ton of stuff actually makes sense, is working, it's easy to maintain, somebody else themselves or their agent can make sense of what was built in there. And in here are some of the things like probably we constantly hear, like we are doing Vibecoding. A lot of people are doing Vibecoding. Everybody can do Vibecoding and build all kinds of crazy things. The code is cheap, right? So code doesn't matter anymore. You just throw things at the agent, output some code, all very cheap, just the cost of tokens, all great. All sorts of crazy agentic workflows that work for weeks or days or whatever and resolve everything. And then one that is very interesting is the fact that AI is replacing engineers. How many of you are afraid of that? Are we going to be replaced? I think we are going to be replaced in the way we are doing engineering now, right? So the things we are doing, the things we used to do are going to be replaced, but that's not something new. I feel like throughout the years, so I've been in the industry for 15 years or something like that, things have changed since 2010 until now. and even before it was different, right? So 20 years ago, you were valued by writing a lot of code. Fast forward 10 years, you are valued by integrating different APIs together, then being able to use some services. You don't write all the services from scratch. You don't write the queues. You don't write the storage and so on. You just go to the cloud and know how to combine them together, build infrastructure and so on. And now we're at this stage where all of that is mostly done by AI. The code is generated, but we need to know exactly what we want, and we need to be able to properly validate that. And one thing that is very close to this, and I feel like it has a lot of hype, and I've tried it myself and I'm still trying at it, is this idea of specs to code. How many of you have written a spec or received a spec or something? I don't know, did it, refined it and so on, gave it to the agent and got something out of that?
Only in the toolkit.
Okay, how many of you were happy with the output of what it produced?
Yeah.
What did you do? Like what, can you give an example?
Small projects in .NET.
Small projects in .NET. Anybody with a production feature, things that were shipped to the customer, like a full product? Yes, that's the thing. This works really well for small projects, pet projects, proof of concepts, and things like this. So there is this idea that you write the spec, you get the code, everything works fine. However, when you check it, the first time you open it, you are, wow, so nice. I have this nice UI, this nice styling. You click two buttons, all they work. Once you start using it more, you start finding issues, right? The things were not completely followed, or you uncovered gaps in your specs. Or if you go to the code, you notice that the code is totally like, I don't know, weird hard codings, bad modules, bad interfaces, and all that. And then you go and say, oh, fine, I'm going to update the specs, fix the things I found, and try again. You try again, and it gets probably worse. And then you try again, and it gets even worse, and so on. Because as the context grows, it's very hard to keep track of the big thing you are trying to build. And we hope that by doing these specs to code, we solve the problem, because most probably we think that the code was the problem. So we have the spec, we have the code, and we say, well, great. We do the spec, and we solve the problem, which is the code. But in my experience, the problem is actually the spec. So that's where the whole thing starts. So in my experience so far, the biggest, I don't know, tensions, issues, delays, and so on, didn't come necessarily from how the code was executed. That can also be the case. But most often comes from how the specs were written, how the specs were understood, the gap in those specs, the mismatch of in the language between the engineering, the product, the business. And it's not to say that it's the problem of the product or the business for not specifying things correctly. Is the fact that there is a language gap and there is a difference between these two domains. And in the end, if you try to do everything at once, this is the old waterfall method, where you build something, you plan everything for the next 2 years, you start working, and then after 2 years, 1 year, whatever, you find out that, oh, we asked for something and we came up with something else, right? So it's this idea that you plan everything from the beginning, and then you hope that at the end you'll get the right thing. The problem is that nobody really knows up front what they want. So when the requirements are vague, that's when the engineering starts. You have to actually work on improving those requirements. And then another tension I have seen is this, that usually when business product comes to engineering, they have an idea or a requirement or something. They come and say, we need to do this. Everybody agrees. We estimate, oh, it's taking 2 months. Why so long? Like, this seems easy. It's very easy, right? So why is taking so long? Now this is getting even funnier, because on top of that, we have the PM, the managers, the business in general, which comes and says, why so long? I've done it. Look, it's working. I've done it. It's just take that and put it into the product. It's done. Why 1 month? Why 2 months? And so on. And this is the trap of the one-shot experiment. And this is where things work great for MVPs, and they are definitely great. And it's great that product people, business people, and everybody else can do these things, and they can actually play with them and experiment and visualize and try out new ideas and so on. But there is a difference between doing all these kinds of experiments and MVPs and stuff and putting them into production. Because when you put them into production, you hit this big enterprise wall where it has to integrate into existing code. There is legacy stuff in there. There are all kinds of things that it needs to pass. There is governance, security, and all kinds of other things you need to account for. And there is a bigger architecture you need to account for, evolve, maintain, and so on. So we end up by just doing things blindly and using all the agents and generating more code, by generating even more technical debt. And the way to generate technical debt is to write code, right? So if you have no code, you have no technical debt. If you write more code on top of that technical debt, you create more technical debt, and so on. And that eventually gets really expensive. Of course, we can go back, refactor, and so on. But again, the more it grows, the harder and the bigger the cost is to fix that. And the issue with that, and is the issue we actually have in practice, because I would say one of the, let's say, problems we have with Copilot and in companies like Microsoft compared to Anthropic and the others, is the fact that they are starting from scratch, so they have nothing else to maintain, whereas bigger companies like Microsoft and all the existing ones, Apple, you've seen how hard for them to integrate in the existing ecosystem. You have to deal with all that legacy. So you have to build on top of that. The things are different. And if you have the technical debt, that's only gonna be amplified. And then also another problem is that we use all these things, and we've done this a lot where I work. Something breaks, there is an incident, there is an issue, who's accountable? Well, Copilot. That doesn't work, right? So you need to find ways to remain accountable, although you generate all the code, you do everything with the agent. At the end of the day, you are still accountable, and this, at least for us, this excuse that I generated the code or whatever, I didn't pay attention and so on, it's not good enough, right? So you do that once, twice, 3 times, then your reviews are gonna start to become negative, right? So taking this into account, what do we actually do and what I'm actually doing? So I'm seeing this as taking the process, which we already know as a software industry and have developed over the years, things we are kind of good at already, and instead of replacing the whole process and everything we learned, we just try to amplify that by using the tools into the right place while trying to remain in control and focus on the important things. So we remove the part of, we use the agents to generate the code, to do the implementations, but it's really important for us to get back to the fundamentals of software engineering, use all the learnings we've done so far, all the things we learned so far, and apply them in the process. So if we break down, like for myself, if I break down the process of addressing something new, implementing a new task, feature, or whatever, because we are mostly talking about not starting something from scratch. Most of us, most of the time, we start something once and then iterate over it, right? So it's not like every day you start from scratch. You start once and then for a while you keep working on something and improving it. So when there is a new task, change, anything that we need to implement, I go back to the fundamentals and to the process that I think helped me grow, develop, and have some sort of impact in the places I've been so far, right? So it comes down to getting that task and not thinking about, oh, I have a task, I just go and write the code. If I do that and just write the code, I don't have to do anything because the code can be written, right? So it starts with design. How do I design? How do I understand those requirements, the task? What do I do? What's the architecture? Then how do I break down the work? How do I iterate in that work? And how do I validate what I did? So on the design part, how do I actually use the agents to to go through this phase. And this is really nice and exciting because whilst understanding and trying to understand those requirements, you can actually use Copilot, any agent, whatever. I'm just going to use Copilot, but whatever agent works, to try to uncover things into those requirements, right? Try to ask questions and scrutinize those requirements, what you would normally do. So normally when you get requirements, you start thinking, oh, what is this? Why am I doing it? What are the edge cases? How does this work? What the users expect, and so on. That takes time. Now, you can also do that, but doing it much faster by using an agent and start asking the questions and trying to understand what's in there and what can you do and so on by using the agent. Then once those requirements are understood and you understand what you need to do, maybe ask some questions, clarify with the stakeholders and so on. Based on those clarifications, I go and say, okay, how can this be implemented? And again, without AI, ideally, you just go and probably you would expect this from some more senior people to go and analyze the code, analyze the architecture, design something, come up with some diagrams, explain how things are done, do some decisions and so on. But now everybody can do this. I can go into an existing code base, I can explore that code base, I can ask the agent to go and do a POC, analyze different options, how I can do this thing I want to change, what are the things I need to change, why change them in this way versus the other, and so on. And when I say this, I'm talking about code bases that they are so large. So for example, I'm working in a project that has, in a solution that has almost 500 projects maintained by a ton of people. And that's only one project. And our work actually spawns across 3 such services, right? Each one has hundreds of projects. And discovering all those, like I'm thinking if I didn't have these, it would have taken me days and days to actually make sure that I understand exactly all the flows, I know where all the changes should be made and so on. But instead, I go and point the agent to the code base and start scrutinizing. So it's not like, tell me how it's done. But I'm just asking the same questions I would ask myself if I had to do it manually. So where is that? What is important? What is not important? What am I missing? Explain me this flow, look at that flow, and so on. So try to have like that scrutiny and the right thinking, but instead of doing it manually, that can easily be automated by the agent. Also using it as an adversarial actor. So challenge you on, oh, I'm thinking this is the plan. How does this plan fit? How does this work? What are the upsides, downsides? What do I break? Why is it bad? So I have this tendency to ask, if I come up with a plan and so on, I ask the agent, why is this a bad idea? Why is this a bad idea? Like, what can go wrong from here, right? And most of the time it comes with different answers. Sometimes it just hallucinates stuff. So not all the things may apply in there, right? But by just giving those, it makes you think about, oh, I didn't think about this, and you can actually take a decision. As I said, you can experiment quickly with new things, do POCs, and make sure that things work in there. And then after that, consolidate the findings and define the plan and come up with a decision. In this process, the things we know from all the learnings in the industry still stand. Like the architecture is important, the clear separation of concerns, the modules definition, the clear interfaces, change management. One of the most important, in my opinion, things in architecture and system design is the change management, so that when you design something, how does that handle change? Because change will come, right? So it's not like I'm designing this now, I build a strong architecture, but the next week when the business says, oh, we have a new use case. Oh, I have to change the whole architecture because guess what? It was so good that it cannot be changed. So for me, I think this is one of the most important things. How do you combine things and create the components and the modules so that you are ready for the change as soon as you ship the code, right? Because that will easily come. So these things are important. And usually, if you do specs to code, they are not going to be given to you by the agent directly. You have to, in my experience at least, you have to look at them and kind of control them yourself, like have a clear guidance about how these things happen. Then once you do that, you break down. So we have this bigger plan. And you go and, just like with the specs, now there are good specs because we did all that. We give them to the agent and things are not going to work, right? So we need to break down. We've done sprints and agile for 25 years, 30 years, almost 25 years, because of the exact same reasons, right? If we start to do a big thing from the beginning, it's very hard to keep up with all the things, with all the cognitive load. It's very hard to adapt to changes because we don't know what we want from the beginning. We realize later that, oh, we might change things. So it's important to break things down in smaller chunks and try to build them iteratively, test them iteratively, validate them, and so on. And I think this is another important skill we should have as software engineers, this ability to break down things in smaller chunks, iterate on them, test them, and validate them independently so that when you put them all together, they work. And this is also important for the agent because, you know, agents have, or models have a context length. And the more you fill in that context length, the worse results you get, right? Because every time all the context is fed back into the model, and it has to reason about a larger context, and it's very easy to miss details from those. If you start iterating over smaller tasks and validate them independently, your chance of actually getting the right output from the model increases quite a lot. Then we have all this, and we need to validate the outputs. On the validation, of course, we have the old things which still work, like linters, code checkers, static analysis, and all that. And these are all great. I think this can still save a lot of tokens. You don't want to just point your agent and say, oh, fix all my semicolons in JavaScript code or whatever, remove all the empty spaces and stuff like that. So that's fine. We still need to use that. But we also have unit tests, end-to-end tests, and so on. One thing that I've seen happening is, as part of this breakdown and implementing the tasks, we go and say, implement the task, and define the unit, and create the unit tests. What happens then is the agent writes the code, whatever it does, whatever it has to implement, and then it creates the tests based on the implementation. I've seen this happening in practice quite often, where the tests were actually validating the bad implementation done by the agent previously, right? So I created an implementation, it was not good. I have the tests, now they validate and they confirm that what I've implemented is actually bad. So 2 ways of avoiding that is, one, go back to the old TDD. So first, create the tests based on the spec, validate the tests, review them, and make sure they are sound. And then use a different session, a different agent to do the implementation and to make sure that the tests are not changed, only focus on the implementation. Or try to isolate the two and specifically create an agent or skill or whatever, and to specifically mention that should start from the tests and do the implementation without trying to change the tests. I had an instance in the past where the agent was so keen on doing the implementation, it ended up hard-coding the answers just to match whatever it needed to do. So it had a bunch of ifs. If input is A, then match the output, and so on. And then at the end, did some bunch of bad logic, which was totally crap. So it was not working, but for the inputs I gave, it was great. And then there are PR reviews. I'm not sure, how many of you, what do you think about PR reviews? But I think it goes back to the fact that we are still accountable. And what I've also seen in practice is that people tend to use agents to do PR reviews. So what happens is I generate the code, I use agents to generate the code. I use agents to review the code. I give it to you. You use the agents to review, and we are done. And then something breaks. We just look at each other and it's like, oh, you approved it. Yes, but I thought you also used the right tools and did the right thing, and so on. So again, coming back to what makes a good software engineer and what you are looking at in the PR reviews is trying to find out and focus on the important stuff, right? So when you look at the PR, don't just look at, I don't know, spaces, code styling, all the nitpicks that everybody likes to comment on, but try to fully understand what's the purpose, how does that make the code better than what it was before, if it's on point, if it matches the specs, and so on. And this, of course, can be done manually, as we always did, but it can be done with agents. So instead of having an agent which says, go and review this and whatever, say what you want about it, I have a skill which goes and scrutinizes that code. So it basically asks, why is this good? Back to what I said in the design. Why is this good? Why is this bad? Why is this a good idea or a bad idea? What are other options? Is this the best option from whatever options may be out there? And so on. And how I usually do this is basically use three separate models with an orchestrator and say, go and review this code base with all these three. At the end, merge them together and explain what were the findings, why did you find them, and what could be a potential fix. And that's because at the end of the day, we are still accountable. And most of the time, I also go and look at the code myself just to, I don't know, have some comfort that I did that as well. So I think we are close to the end here. What I want to remain from this presentation, the main message is that although we are moving at the speed of light and we have a lot of tools and a lot of exciting things coming and a lot of change, all the old fundamentals of software engineering still matter and I think are more important than ever. That's because technical spec writing, if you don't know how to do that and you write bad specs, there's no way you can get good outputs from that, right? And you can use AI to improve that technical spec writing. If you have a bad system design, bad code, a lot of technical debt, spaghetti code, and so on, when you put AI into that, it's gonna get even worse and things are not gonna work. If you don't manage the tasks correctly and you give a big chunk of things to be done from one go, it's not gonna work right. How do you communicate with the agents? This is also an important skill. Like if you are talking to your colleagues and they don't have no idea what you're saying, if you talk to the agent in the same way, it's gonna be the same, right? So clarity, communication skills, how you are able to focus on the important stuff and explain things clearly. They work with the agents as well as they work with the other humans. How do you scrutinize the system and how your ability to read and understand codes in the code reviews and looking at the important stuff. So what does this mean for us? I think that for junior engineers, this is great. So they say that junior engineers are gonna be replaced first. But that's going to be a problem because if we replace junior engineers, there will be no more senior engineers to get to that level because there are no more junior engineers to start with. So I think as a junior engineer, this is a great opportunity because, as I said earlier, it shifts this idea that design and thinking and all the planning and so on, it's only for the more senior people, the architects and so on. Now, as a junior engineer, I can use all these tools to tap into whatever, like build diagrams, explore the system, experiment with stuff, create architecture, make sure that that architecture is good enough, and so on. Do proper code reviews or understand better how to do code reviews and so on, use these tools. And as a senior engineer, this is great because you can actually deliver a lot more by just applying the process which took you to become a senior engineer, lead, architect, whatever. In order to get there, you actually have these skills already built in, I suppose. You learn them already. And just using AI and the tools, will just amplify this and will let you deliver a lot more faster and with better quality. And yeah, that's it. Thank you very much for listening. Yeah, if you have questions.